Welcome to EPG Pathshala in Computer Science, series of lectures on computer networks. We have been looking at the different protocols for multimedia support. So, we looked at the RTP protocol, which is the real time transport protocol. So, now we will be looking at the RTCP protocol, which is the companion protocol for RTP. So, RTCP is our real time control protocol. So, we will look at the functions of RTCP, we will look at the format of messages, and we will look at the use. Okay. So, this is just a quick overview of the protocol stack for real time applications. So, for real time applications, as we said, on top of UDP and TCP we have a few more protocols that have been provided. So, some for signaling, SIP and S.323, then we have RSVP for quality of service, RTSP for streaming control, then you have this RTP, RTCP, which are basically used for media transport. So, we've seen what the real time transport protocol RTP protocol does. It is essentially a framing protocol for real time applications, does not define any QoS mechanism for real time delivery, but it has enough support for real time applications. This is what we looked at when we talked about RTP protocol. Now, the RTCP protocol, it is a companion protocol to RTP. Again, it does not guarantee any quality of service as such, but it provides the feedback that is required for applications to adapt to the conditions of the network. Okay, based on end-to-end information. So, all this feedback that we are talking about is from the end machine to the other end machine. It may be the source giving feedback or giving some information to the receivers, or it may be receivers giving feedback about what they have received to the source. Okay. So, this is what you have as part of the RTCP protocol. Okay. So, as I said, RTCP works in conjunction with the RTP protocol. And what RTCP demands is that every participant that you have in the RTP session will periodically send these control packets to all other participants, okay, not just to the sender, remember, to send to all other participants. This is a point to note. So, everybody will get to know who is receiving packets from whom, okay, and what is the actual status of the entire session. So, we are talking typically about RTP sessions here where you have multiple users, right. So, typically audio conferences, video conferences and so on. Okay. So, we would like to know the status of everybody, all the receivers and all the senders. Okay. So, if you have, what you normally have is a sender will send RTP packets for the data that he or she is sending, and the sender will also send RTCP packets into the network. Okay. Now, RTCP packets will be sent by the receivers as well. So, sender will send RTCP packet plus the receivers will send the RTCP packets. Note that RTP of course would have been sent only by the sender, but RTCP packets will be sent by everybody. So, this is the basic principle that we need to keep in mind. Okay. So, as part of the RTCP protocol, every RTCP packet will contain what are called as sender and or receiver reports. What we mean by and or is that if it is a sender sending something, it will have only a sender report. If it is a receiver sending a report, it will have only the receiver report. If it is a sender sending a report, sender will give information about the data it is sending plus information about the data that it has received from other senders. Okay. So, that is the idea that we use here. So, we will see this in detail. So, you will have full statistics which are useful to the application. You will have information like number of packets just sent, number of packets which are lost, the inter-arrival jitter that is there. Okay. All information related to this is carried as part of the RTCP packet and given back as feedback to the source. Okay. And this feedback control can be used to control the performance of the application. Okay. For instance, the sender may modify its transmission based on the feedback that it gets. Okay. So, basic objective of the real time control protocol is that you want to report these things, end-to-end delay, delay jitter, loss rate and so on. Okay. And what is the purpose for which you are sending this? So that the sender can switch to a lower bitrate codec or do some adaptations so that the user will get a smoother real time experience. So, that is the basic objective. So, in general, if you look at the various characteristics of the RTCP protocol, okay, you will find that it will have to definitely send periodically it will have to send packets. So, periodic transmission of control packets is necessary because you need to know what is happening in the network. So, periodically you will be sending these RTCP packets. And there are several functions that these RTCP packets will support. Okay. One is it will provide feedback on the quality of the data distribution, how the data is getting distributed among the different receivers. Okay. And it lets everybody evaluate the number of participants, lets everybody evaluate the kind of reception that all of them are getting. Because remember we said the packets, the RTCP packets will be sent by every receiver. It will be sent to all the participants who are there in the session. Okay. And it also allows you to have a persistent transport level canonical name for a source, which is called as the CNAME, canonical name. Okay. We said that we would like to have something which is other than an IP address as an identifier for a source. Okay. We talked about this when we talked about the design philosophy of RTP protocol. So, that requirement is actually taken care of in the RTCP protocol, because remember RTCP is after all a companion protocol to RTP. So, the load basically the responsibilities are shared between RTP and RTCP. Okay. So, as part of RTCP protocol you will be able to specify a canonical name for a source. So, normally you can specify it something less user at some host, you can give a name like that. Okay. And this will not change even if the SSRC, that is the source, the synchronizing source identifier that we have in the RTP protocol, even if that changes, this will not change. Now, the SSRC, if you look at in the RTP protocol, is basically a random number that is assigned when a source is sending some data. Okay, but that for that session, that SSRC will remain constant. Okay, will remain the same. But even if SSRC changes, this CNAME will not change for the user. Okay. So, it kind of helps us to provide a binding across multiple media tools for a single user. So, when you have an audio stream that may have a different SSRC, video stream may have a different SSRC, but using the CNAME you will be able to connect that both these streams belong to the same multimedia application or tool. Another important aspect of RTCP is that it uses the same distribution mechanism as data packets. So, if you talk of RTP data packets, RTP supports unicast and multicast, right. Typically an end-to-end multicast is supported in RTP. So, that same mechanism of end-to-end multicast is what is used in by RTCP also, because remember it is after all it also has to send all the information to all the members who are there in that particular group. Okay. And multiple RTCP packets can be concatenated by translators or mixers. Remember we talked about something called a mixer when we talked about RTP. So, if you have a mixer device which basically takes data from different sources and combines them together, similarly that mixer can also combine the RTCP packets and send it as a single RTCP packet for this combination of different sessions. So, that is called as a compound RTC packet. Another important aspect of RTCP is that it has to scale with the session size. Okay, that has to be ensured. Now, remember RTCP packets are sent by all the participants in the network, and we said it has to be sent periodically. Now, what should not happen is that if you have large number of participants, we should not end up in a situation that the number of RTCP packets being sent is so large that it consumes a lot of the bandwidth of the network. Okay, that is a possibility, right, if you send too many RTCP packets, right. So, you have to make sure that whatever be the session size, that is how many ever participants are there, the RTCP traffic will not exceed a certain percentage of the total session bandwidth. Normally that is fixed at about 5% of the total session bandwidth. Okay. So, which means you should be able to evaluate the number of participants that are there and accordingly determine how many RTCP packets you are allowed to send. This every receiver should know how many receivers are there altogether, right. So, if there are few number of receivers, then you have 5% of the bandwidth is only divided among the few of them, right. So, you get a higher number of RTCP packets that you are allowed to send. But if the number of users increases, then you will have to make sure that you do not send packets that frequently, so that everybody is able to share that 5% bandwidth that is allotted for RTCP traffic. Okay. So, this scalability with session size has to be built into the RTCP packet. Okay. And out of this RTCP 5% that is allotted for RTCP, at least 25% of that is for source reports. Okay. So, that now why should this be done? Because whenever a receiver, for instance new receiver joins, he should know who is the source, right, who is the one who is sending these reports. So, he should know what is the CNAME of the sources which are sending the packets, right, sending the RTP packets. So, in order to give a quick information about the sources must be allowed to send their packets, their information, okay, whatever information that is being sent in the source reports, that it should be allowed to send quite frequently. So, this is basically the these are some of what do you say the characteristics as such of that RTCP should hold, okay, should have. Okay. Right. Now, coming to the packet header, okay, how is it that all these characteristics are handled in the RTCP header? Okay, if you look at the RTCP packet, so it has a header followed by data. So, the header will have information about again there is a version field, there is a padding field, There is something called an item count which talks about what this again will vary depending on what kind of RTCP packet we have, and there is a type field here. The type field basically tells us what kind of an RTCP packet is being sent, and there is a length field which gives you the length of the packet. Okay. So, now if you look at the type field, right, so we have different types. You have a negative ACK, then you have SR, which is a sender report, which is used to specify transmission statistics, that is what exactly has been transmitted. So, this is sent by the sender. Then there is an RR, a receiver report, which is meant to carry receiver wise statistics. So, sent by the receivers, by each of the receivers. And there is something called an SDES packet, which is a source description packet. Okay, it will have items such as this canonical name and other things that we talked about. So, this will be sent by the source. And there is a by packet, which is basically sent by the participant to end when it is exiting the session. When it wants to end its participation, it sends out the by packet. And then there is an app specific packet, which can be used to carry some application specific functions, which can be used to carry application specific information. Okay. So, these are the different categories of RTCP packets that we have. We will take a look at each of these now. Okay. So, if you look at this receiver report packets, so information that will be kind of conveyed in the receiver report packets will be of this nature. It will talk about fraction of packets which are lost, the last sequence number that was received, average inter-arrival jitter. Okay, these are all very important parameters which are carried in the receiver report packets. Sender report packets will have information about what is the SSRC of the RTP stream, so that you can associate that this source is what is actually sending me the stream. Okay, current time, okay, number of packets that are sent, number of bytes that are sent, and so on. Okay, and the source description packets, the SDES packets, will have information such as email address of sender, sender's name, SSRC of the associated RTP stream, okay, and so on. So, it basically provides a mapping between the SSRC and the user or the host name. So, you use that to connect up multiple SSRCs as such. So, the SR packets, okay, these sender report packets will have the following information. It has the SSRC of the sender, which will identify the source of data. It will have the timestamp, okay, of the NTP timestamp. So, this is the timestamp of when that report was sent. It also has the RTP timestamp, which has the corresponding RTP time, right. So, this RTP time is the timestamp that will be used on RTP packets. Remember, RTP timestamps are based on clock ticks. NTP timestamp, here this timestamp is a wall clock time. Okay. So, you can kind of use this NTP RTP combination which is given in this SR packet to synchronize the RTP times with the actual wall clock times. Okay. So, this relationship that we get from this is what will be used to interpret the RTP packets, the timestamp information that is there in the RTP packets. Okay. So, this is a very important aspect. And then there is a packet count which tells you the total number of packets sent. There is an octet count which also tells you the number of octets that are sent. Now, octet is it's an 8-bit field. Okay. And this is the source related information. This will be followed by 0 or more receiver reports. So, what do we mean by that? Because the source is also receiving data from other sources. So, it will also give information about what it has received from those other sources. For example, let us say source 1 is giving a report and there are 2 other sources available. So, what will the packet look like? The RTCP packet will have information like this. It has the SR, which consists of first the SR header followed by the sender report. The sender report is report of source 1 as the sender, and it gives a receiver report of what it received from source 2, from source 3 and so on. So, this will be the overall RTCP packet. Okay, the SR RTCP packet will be like this. So, this is just again the same information given as a packet format as such. You can see that all these information is available. The timestamp, there are 2 fields that are used, the most significant word and the least significant word. And then we have of course the RTP timestamp, then various things that we talked about now. Okay. So, this is the SR packet format. Now, if you look at the receiver report RTCP packet format, so it will have information about the SSRC of the source. Now, because we need to identify the source to which this RR block pertains, that is, you are reporting about the data received from a particular source. So, you are saying which source I am reporting data about. The fraction loss, that is, number of packets that have been, or the fraction of packets that have been lost since the previous report was sent. The previous report could be an RR or it could have been an SR that was sent. Okay. So, this is given as 256 times loss divided by expected. Okay. That is how the fraction is calculated. And then the cumulative number of packets lost. So, this will give us an indication of the long-term loss, long-term loss that has taken place. And then the highest sequence number received, okay, so this again can be used to compare losses. It also gives information about the inter-arrival jitter. So that is when packets are received, if there are variation in the delays, so that jitter information, the inter-arrival jitter information is calculated, smooth inter-packet distortion information, and that is conveyed as part of the RR packet. And then we also have the LSR, which is the time of the last SR received, that is the LSR. So last instant at which the SR packet was received from that particular source, right. And DLSR is the delay since the last SR, that is from the time that I received that SR, right, what is the delay for me in sending this RR pertaining to that particular SR, okay, pertaining to that particular source. So that information will be specified over here. We will see how these fields are useful for calculating some very important information about the network's performance. Okay. So this is the RR packet as such, the packet format. You can see that all the fields that we talked about are all mentioned over here. Okay. Okay. Now the other packet format that we talked about was SDES, the source description format. Now the source description will have again the source identifier, SSRC or CSRC of the sender, followed by some information about the source given in a type length text format. Okay. So that is the encoding that is used. So you may have information about CNAME, the canonical name, name of the source or the person, maybe email address, phone number, location, okay, some tool that they are using, various information related to the source. These are things that are specified as part of the SDES packet. The app, so this is the format of the SDES packet. If you look at the app packet and the BY packets, right, there are these two other packets that we need to look at. The BY packet, if you look at, so this will have again the SSRC or CSRC of the sender, and it specifies a length field and gives you the reason for leaving, okay, the reason why you are leaving, exiting a particular session, okay, that information will be specified as part of this BY packet. So it could be used by the service provider or by the other participants to understand why a particular participant is leaving the session. Okay. And the app packet we said will be used to carry some application dependent data, right. So it is a very simple format. You have the sender's SSRC followed by name, followed by whatever application dependent data is expected to be sent for that application. Okay. This is defined based on the application. These are all application defined information. Okay. So we said that the fields that are there in the RTCP packet can be used to calculate certain important parameters. Okay. So one of those parameters that we can calculate is round trip time. Okay. What is the round trip time for this data? Remember, round trip time is time taken for my data to go from here to there and for me to receive something from that end to this end. Okay. So if you look at how that can be calculated, the round trip time, so look at what is happening here. When a sender sends an SR packet, right, it has the NTP timestamp that is there in that particular packet. Okay. So when the receiver receives that information, the last instant at which this SR packet was sent, that is what it is going to send you back in its RR report as the LSR information, that is the time at which the last SR was heard. Okay. The last SR that I received, the source report that I received, sender's report that I received, what was the timestamp on that? That information is the LSR field. Okay. And you are also going to have the DLSR information in your RR packet, which tells me the delay since the last SR. What is this delay? From the time I received this SR to the time I am sending this RR, what was this delay, right? So this time is what is my DLSR. So this DLSR information will also be specified as part of the RR. Now how can I use this to calculate the round trip time? It's very simple, right? I can note the time at which I am getting this RR report, let us call that A. So now A minus LSR is my total time, right, from the time the packet was sent to the time that I am receiving this, minus I just subtract this DLSR because there was a delay in sending this packet because RTCP could not send the packet immediately, right. So there was some delay. So I want to remove this delay. So I want only time taken for SR to go from here to here plus time taken for RR to come from here to here. Okay. So if I want only this time plus this time, how do I calculate that? That will become A minus LSR minus this DLSR. Okay. So this delay that I have, this becomes my round trip time. So A minus LSR minus DLSR can be very easily used to calculate the round trip time. So using the information that is there in the RR packet, you will be able to do this. Okay. This is one simple parameter calculation that we talked about. Similarly, we said that the inter-arrival jitter is reported. Okay. So how is this jitter calculation done? Okay. So again this is done with the help of the timestamps that we have. So let us say SI is the RTP timestamp for packet I. So when the RTP packet is received, let us say I received it at timestamp on that packet was SI. Okay. So RI is the time of arrival, okay, in RTP timestamp units for packet I, okay, in terms of that RTP timestamp units. Let us say Ri is the time of arrival of that particular packet. Now for the two packets I and j, okay, so the deviation or the deviation from the delay, okay, can be calculated as, basically what is the deviation for jth, the delay for jth packet you can say is Rj minus Sj, right. Similarly, delay for the ith packet is Ri minus Si. Now what we are interested in is the difference in these delays, right. So difference in delay will be Rj minus Sj minus Ra minus Si, okay, or you can look at it as Rj minus Ra minus Sj minus Si, okay. So you can calculate this deviation from the delay in successive packets delays, okay. So once you calculate this delay, now I can use what I need basically is an average value of this delay, right. I want a weighted average, a weighted moving average of this delay. So how do I calculate that? You take the absolute value of this d between calculate over two successive packets I minus 1 and I, okay. You take that and weight it by a factor of 1 by 16, okay, and weigh the the jitter that you have, okay, that by another factor. So you take a weighted average of these two factors, right, the original jitter plus the current value. So these two are taken. So you are giving a lower weightage to the current value 1 by 16. So you can see you have j minus 1 minus j minus 1 by 16. So a 15 by 16 weightage will be given to the previous value of jitter. So 15 by 16 into ji minus 1 plus 1 by 16 into d of I minus 1 comma I. That will give me a weighted average for the jitter. So this weighted average is what will be reported in the RR packet. So you calculate the jitter and report this in the RR packet. So once this is reported, accordingly, of course you can adjust your play out time based on this jitter that you have calculated at the receiver side, and the sender and all the other receivers also get to know about the variation that is there, the delay variation that we have, and accordingly they may do whatever adaptations are required. Okay. So that is about the jitter calculation. Now talking about stream synchronization, okay, we said that different media streams can be there as part of an RTP session, and you will have to synchronize these, okay. So RTCP we said helps do the synchronization, okay. So for instance, let us take something like this. Let us say it is a video conferencing app. So each sender generates one RTP stream for video and one for audio, let us say, okay. So now what will happen, the timestamps will be there in the RTP packets, okay. They are tied to the video sampling clock and to the audio sampling clock. They are not tied to the wall clock time, right. So because remember when we talked about RTP, we would have seen that the timestamp correspond to the sampling time, right. So so the granularity of the timestamps there is related to the sampling clocks, not to the wall clock time, okay. So video will have a different sampling time, therefore the timestamp of video is at a different granularity, audio samples are at a different granularity. So how do I actually synchronize these two? How do I say that this piece of video and this piece of video are these two different timestamps? They actually belong to the same media stream, okay, at the same instant, that they both correspond to the same instant of time, same physical instant of time, okay. That is done with the help of the RTCP packets, because RTCP packets will report the wall clock time corresponding to the RTP time, okay. That information is what we have to use, okay. So the RTCP sender report packet will contain this information, right. For most recently generated packet in the associated RTP stream, it will have the timestamp of the RTP packet, and it will also give you the wall clock time for when that packet was created. So I have now information about what was the timestamp of the RTP packet and its wall clock time. So using this, right, now you can synchronize the two different streams that are there. So I can find out the wall clock time corresponding to the timestamp, and I also know the granularity of the timestamp. So I know at what rate those timestamps are generated. So using that, I will be able to now identify what is the wall clock time for that of one stream, what is the wall clock time for another stream, and then the receiver can use the association to synchronize the playout of audio and video. Okay. So that is how the RTCP packets help for synchronization of the audio and video streams. And when you have multiple multicast senders, so you can see that each RTP session will typically be a single multicast address, and all RTP and RTCP packets belonging to the session use that same multicast address, okay. So in a multicasting session, that is what will happen. And RTP and RTCP packets are distinguished from each other via distinct port numbers. We saw that RTCP will always use one number more than the port number used by RTP. But what is also important is when you have a multicast session, you need to limit the RTCP traffic. So, each participant will reduce the RTCP traffic as the number of conference participants increases. Okay. So, this is something that you will have. Okay. So, we saw this already, right. There will be multiple RTCP packets that are sent by different receivers, right. So, we need to look at how RTCP will be able to limit its bandwidth. Okay. Each participant should be able to limit the amount of data, amount of traffic it is sending. So, how does that happen? So, if you look at RTCP traffic, there are a number of factors that have to be considered. Normally, we said that RTCP traffic is limited to 5% of the session bandwidth. Okay. So, the total bandwidth required for a RTP session therefore will be whatever is the session bandwidth, the RTP session bandwidth plus 5% of the session bandwidth. So, this will be the total bandwidth requirement. Okay. And we said that out of this RTCP's reserved bandwidth, 1/4 will be used for senders. Okay. Of course, it can be modified based on the profile, but normally 1/4 of the available 5%, right, is reserved for senders, and it is the rest of the 3/4 of the 5% which has to be shared by the receivers. Okay. Now, you can also have different bandwidth for active and non-active participants. So, that is also a possibility. Okay. And we need to calculate bounds on the time interval between RTCP packets. So, that is every receiver when it is sending out or sender when it is sending out the RTCP packets, it has to find out if it has just sent a packet after how long a time it can send the next RTCP packet. Okay. So, this time interval between RTCP packets is supposed to be calculated by each participant depending on the information about the other participants that are there in the network. Okay. So, if this time interval is too small, what will happen? There will be too many RTCP packets that are being generated. It will lead to bursts of traffic. If the time interval is too large, what will happen is it can lead to transient outage. That is, you won't get any information at all for a very long time about a particular source or a receiver. So, that is also not advisable. So, we need to have again a kind of a trade-off, right. You need to find out the appropriate value of time interval to use. So, how can we do that? So, the minimum time interval is normally based on the number of participants. Okay. Now, how will I know about the number of participants? I will keep track of how many RRs you are getting from different receivers. So, that itself will give me similarly how many SRs you are getting. So, that will give me number of senders, you will get the number of receivers. Okay. Both information is known to us. Okay. And the minimum time interval for a new participant, when a participant joins the conference, within 5 seconds he will have to send his report, because you need to know that a new recipient or whatever has joined, right. So, that is always fixed at about 5 seconds, or it could be made lower to even 2.5 seconds. And the time interval subsequently is calculated as a function of number of members, number of senders, the average RTCP packet size and the RTCP bandwidth. Okay. So, we said RTCP bandwidth we know, right, we will know what is the bandwidth that is allocated for this, and the average RTCP packet size we will be able to calculate because we are seeing the different RTCP packets that are being generated. We can keep track of the number of senders and the number of members that are there. Based on these factors, you calculate the time interval. Okay. So, we say time interval is calculated as a function of these various parameters, and based on this time interval, you will send out the RTCP packets. So, how is the bandwidth scaling therefore handled in RTCP? As I said, it attempts to limit its traffic to 5% of session bandwidth. So, let us look at an example to see how exactly the scaling works out. So, let us say there is one sender sending video at 2 megabit per second. So, RTCP will attempt to limit the RTCP traffic to 5% of 2 Mbps, which will come to about 100 kilobit per second. Okay. Out of this, we said 25% will be allotted to sender, 75% is given to the receivers. Okay. So, that is the first part. So, which means 75 kilobit per second will have to be equally shared among the receivers. So, if there are R receivers, each receiver will get to send RTCP traffic at 75 by R kilobit per second. Okay. That is the rate given to each receiver, and the sender will get to send RTCP traffic at 25 kilobit per second. Here we had only one sender. Okay. So, he will get the 25 kilobit per second to send his RTCP traffic. Okay. And each participant will determine the RTCP packet transmission period, that inter RTCP packet time, by calculating the average RTCP packet size and that is across the entire session, and dividing it by the allocated rate. Okay, it knows what is the rate allocated to it. So, it based on the allocated rate and the packet size and the total bandwidth that is available, right, it will calculate the inter-arrival time. So, this is how RTCP will handle the bandwidth scaling. So, there are more number of users, you will find that the 75 by R, this R factor will increase. Therefore, each person's share will become less. So, they will be able to send packets less frequently. So, that is how it will handle this. Now, this another feature of RTCP which is called as the compound RTCP. So, we mentioned this when we talked about mixers. That is, when you have many RTCP packets from a participant that need to be for instance grouped together. Okay. So, then you send what is called as a compound RTCP packet. So, this compound RTCP packet will consist of a fixed part plus a number of structured elements of RTCP types. Okay. For instance, you could have an SR or RR normally should be sent in each compound RTCP packet, plus an SDES information will always be included. Now, why should the SDES information be always included? This is for new receivers to receive the CNAME of the sender as soon as possible. Okay. So, that is why that will be included. And normally mixers or translators, they will combine RTCP packets into compound packets. So, they will make sure that they take information from various sources, and when they are sending out a single mixed RTP packet. So, similarly, they will also take different RTCP packets from these different sources and send them as a combined RTCP packet. Okay. So, that is how the compounding of the RTCP will be done. So, to summarize, we have looked at various features of the RTCP packet. So, we have looked at what is meant by a sender report, we have looked at what is a receiver report, we have looked at how the bandwidth requirements are handled and how the RR and SR packets are used to calculate various performance related parameters for a given session. Okay. So, with this RTP and RTCP, you can see that this combination, okay, gives a lot of features for multimedia applications to be able to adapt to the condition of the network and share the available bandwidth in an effective manner. Thank you.